Hey there.
You're good, Ed.
Great, thanks.
Good afternoon, everyone. Welcome to Conservation Conversations. My name is Ana Sangronis, and I work for the University of Florida IFAS Extension Service and Florida Sea Grant here in Miami-Dade County. This webinar series is a joint effort between UF IFAS Extension, Florida Sea Grant, and Miami-Dade County Eco Adventures. We will be offering this webinar series every Friday at 1 and 5 p.m. for the foreseeable future. While we can't see you in person right now, we're really excited to offer this series and connect with you despite all that's happening around us. Thank you for tuning in today. Everyone in this webinar is currently muted, so I ask that you type any questions you may have into the chat box, which I will be moderating. We'll be answering questions at the end of the session. This webinar is being recorded, and a link to the recording will be sent to you within the next few days. Please follow us on social media, where we will be announcing Friday's conversation topic at the beginning of each week. If you'd like to receive an email reminder with the weekly conversation topic and registration links, please email me or let me know in the chat box. I'll be putting my email address in there in a moment. Now I'm going to turn it over to today's presenters, Heather Tedlow and Ed Pritchard of Miami Eco Adventures.
Thank you very much, Anna. Well, good afternoon, everyone, and thank you for joining us for today's conservation conversation, which is entitled, Is It Getting Hot in Here? Climate Change 101. This is just going to be a brief overview of climate change, and we're hoping that today's conversation will branch off into some other conversations, or we can get into a little bit more depth into some of the topics or issues that we're going to be discussing today. So just so you know who's speaking, I'm Heather Tedlow, and my colleague Ed Pritchard will be joining me to discuss some impacts of climate change a little bit later in the presentation.
Hey, everyone.
So Ed and I just became certified CLIO Institute climate speakers. For those of you that do not know what the CLIO Institute is, the CLIO Institute is a 501c3 nonprofit, nonpartisan organization exclusively dedicated to climate change education, engagement, and advocacy in Florida. Ed and I completed a cohort of the CLIO Speakers Network, and the goal of the CLIO Speakers Network is to build individual speaking capacity to simplify climate science, its seriousness, and solutions for the general public. For more information on the CLIO Institute and the programs that they offer, you could visit their website, which is clioinstitute.org. So the overview of today's presentation, we're going to discuss the science behind climate change, the impacts of climate change here in South Florida, and solutions to combat the climate crisis. So why is this topic important to Ed and myself? Well, growing up in South Florida and being native South Floridians, we remember as children celebrating the winter holidays in sweaters. Now we're celebrating the winter holidays in shorts. Working for the Miami-Dade County Parks, Recreation, and Open Spaces Department, we see the impacts of climate change at work. We see flooding in our coastal parks and marinas, saltwater intrusion affecting terrestrial plants, the erosion of our beaches, and we can feel our waters getting warmer, and we see the impact of warmer waters on marine life. And for an example, what we're gonna be watching here is a video of Crandon Marina during a king tide event, and our staff member, Crystal Espinosa, provided us this video. And as you can see, we're about to launch a tour. There's our kayak participants, and our kayak participants and kayak participants and kayaks are standing in the parking lot of the marina. Our launch point is where the little hand is pointing over there So we're already have the kayaks in the water way before we actually are getting to the launch ramp. So before we get into the nitty-gritty of our presentation, we want to have you guys complete a quick poll. The poll is 5 questions, so make sure you scroll down and answer all 5 questions for us. And we'll give you a moment to complete that. If we can begin wrapping up the poll, give you guys a few more seconds. Go ahead and we can close the poll. Okay. We can move on. So besides my personal observations and Ed's personal observations, we also have science that backs us up. In fact, 97% of actively publishing climate scientists agree that global warming trends are happening and they're extremely likely due to human activity. And the human activity that is causing these climate warming events to happen is the industrialization of our civilization. Basically, the burning of fossil fuels, and the burning of fossil fuels is leading to an excess of carbon dioxide in our atmosphere. 80% of carbon emissions comes from the burning of fossil fuels, and those fossil fuels are coal, oil, and gas. In the United States, 81% of our energy comes from the burning of fossil fuels. It's also important to note that greenhouse gases do naturally occur in our atmosphere. And greenhouse gases are heat-trapping gases. And it plays a role in a natural effect called the greenhouse gas effect, or the greenhouse effect. Basically what happens is heat energy from the sun penetrates our atmosphere, reflects off the surfaces of the earth, like in infrared rays, and then those rays head back up toward outer space, and the greenhouse gases trap that heat and blanket the earth. Without the greenhouse gas effect, the earth would be a frozen tundra and be uninhabitable. The earth's average temperature would be approximately 0 degrees Fahrenheit or negative 18 degrees Celsius. The issue at hand now is a balance is thrown off due to the excess amount of greenhouse gases in the atmosphere, and the Earth's climate is changing due to the excess greenhouse gases. We also want to point out that sometimes the terms global warming and climate change are used interchangeably. Global warming is a little piece of the climate change puzzle. So global warming refers to the rising global temperatures due mainly to increasing concentrations of greenhouse gases in the atmosphere, versus climate change, which refers to the increasing changes in the measure of climate over a long period of time, which includes temperature, precipitation, and wind patterns. So as I mentioned, the issue is not the fact that we have greenhouse gases in our atmosphere, but the issue is too much of those greenhouse gases are in our atmosphere. And carbon dioxide is the main contributor. 81% of the greenhouse gas emissions in 2018 was carbon dioxide, but there are some other greenhouse gases that play a role that are also based on human activity. So methane, 10% of the greenhouse gas emissions in 2018 was methane, and methane comes primarily from agricultural activities. 7% is nitrous oxide. Nitrous oxide usually comes from fertilizers, and 3% come from fluorinated gases, which we use in cooling, such as refrigeration and air conditioning. The Earth is getting hotter, and over the last 5 years have been the hottest on record, which is leading to some serious impacts on our planet. And as I mentioned, the main driver of the climate crisis is carbon dioxide. Why is this happening? Because we're industrialized and we're burning those fossil fuels. And you can see on the pie graph on the left, what countries or areas are the largest contributors to the burning of fossil fuels. China is at 30%, followed by a group other, which is probably a bunch of countries lumped in together. The United States is a contributor at 15%. The European Union, which is made up of 28 countries, 9%. India at 7%. The Russian Federation, 5%. And Japan, 4%. So this graph is really important, this slide here. And it shows quite a few things. It shows us the natural changes of greenhouse gases in the atmosphere versus human activity change. So as you can see historically, over a long period of time, over history, the carbon dioxide in the atmosphere has stayed at a relative range between 200 and 300 parts per million. And as you can see, there's natural cyclical movement. When we have low points where it's at 200 parts per million, we're seeing ice age events. And at its highest points, we're seeing the Earth at a little warmer when it's at 300 parts per million. In the year 1950, we start seeing a spike in the amount of carbon dioxide in the atmosphere. And we start seeing that steady rise due to the industrial revolution, so the burning of fossil fuels. And scientists are able to determine what is natural carbon dioxide in the atmosphere versus carbon dioxide that gets into our atmosphere caused by the burning of fossil fuels. So currently, as we stand now in our atmosphere, we have 413 parts per million of carbon dioxide in the atmosphere, which is greatly above that 300 parts per million threshold. And that's leading to definite impacts on the environment and causing impacts that if we don't address now, we might not be able to reverse. Ed's going to take us through some of those impacts now.
All right, thanks, Heather. So let's talk about some of the impacts that we're seeing globally from this warming of our planet. So let's start with ice. So what is happening to Earth's ice? So ice serves as like Earth's natural air conditioning system. So large land-based ice formations naturally retreat each summer, but with the unusually warm temperatures, we've seen greater than average melting. And when we talk about the ice, we're talking about two different types of ice. We have sea ice, which is frozen seawater and icebergs. When it melts, it does not directly add to sea levels because it's already in the sea. So the volume's already accounted for, but when it does melt, it exposes more dark ocean. And so when you have those dark surfaces, it absorbs more heat as opposed to when the white ice reflects that heat, and that's called albedo effect. So with this melting of the ice, we're encouraging more absorption of that heat. And then we have land ice, which is ice sheets and glaciers. So when this melts, through gravity, it eventually finds its way to the nearest body of water. So that land ice melting can directly add to the volume of water in the ocean. And so that's what's causing sea level rise. So let's talk a little bit more about that warming of the ocean. The ocean is the largest solar energy collector on Earth. Not only does the water cover more than 70% of our planet's surface, but it can also absorb large amounts of heat without a large increase in temperature. So this tremendous ability to store and release heat over long periods of time gives the ocean a very central role in stabilizing Earth's climate system. But again, rising amounts of greenhouse gases prevent heat from escaping into space. So most of that excess atmospheric heat that Heather mentioned is reflected back, is passed back to the ocean. So as a result, a lot of that heat is absorbed again at that upper ocean levels. So that heat content has increased significantly over the past 2 decades. As you can see by the diagram from NOAA, our record warmest, this is ocean and land temperatures. You can see those areas where in the open ocean, where that heat is. And so as water warms, the volume expands. And then as the volume expands, the seas rise. So oceans have absorbed about 93% of the excess heat caused by greenhouse gases. And with that, oxygen concentrations are also declining. So a warming ocean loses oxygen for 2 reasons. First, the warmer a liquid becomes, the less gas it can hold. So therefore, it's just like a carbonated beverage. If you were to leave it out in the sun, it goes flat faster. So, you know, again, that oxygen is being lost there. Secondly, as polar sea ice melts, it forms a layer of, you know, buoyant water at the sea's surface. Again, it's fresh water, and it's going to sit above the colder, more saline waters, the more salty waters. So you're going to have that layer on top. And so the process creates kind of a lid that can keep the currents from mixing the surface water into those deeper depths. So you're losing that oxygen there as well. And then lastly, oceans currently absorb more than 1/4 of the CO2, causing what we call ocean acidification. And that's basically when water and carbon dioxide combine to form carbonic acid. In this process, the combination decreases the amount of calcium carbonate in the ocean. And calcium carbonate is really critical to a lot of ocean organisms that use that calcium carbonate to build their skeletons and shells. So those are things like oysters, clams, sea urchins, and especially corals too. So those hard corals, the stony corals, they build the structures of reefs. They use that calcium carbonate as well. So how does that impact also, you know, us? I mean, today more than 1 billion people worldwide rely on food from the ocean as their primary source of protein. And then thus both jobs and food security in the US and around the world depend on these organisms. And it can really disrupt the food webs when you have these organisms not able to build those skeletons and shells. So those are just some impacts from warming oceans. So let's talk about the impacts of climate change, both to us, our health, as well as to wildlife and some of our natural resources. And we're gonna focus specifically on impacts here in South Florida. And these are direct relation to temperature, precipitation, and sea level rise. So let's start with sea level rise, because this is something that we see in the news and something that, you know, a lot of us in our communities, we see pretty frequently. So if you look at this graph from NOAA, you can see between 1900 and 2020, this increase, it's in meters. 0.15 is about half a foot. So you can see this increase up to 2020. We've seen that increase of the seas by that much. And then the projections are that by 2050, approximately 2.5 feet of sea level rise is expected. And then extending out to 2100, where it's possible that we could see between 8 and 10 feet. And so obviously that's gonna have major impacts. Here in South Florida, we sit at sea level, you know, on our infrastructure and on our way of life. So looking a little bit more closely, we're seeing this again in our communities. This image is from Miami Beach. And in Miami Beach, again, they've spent billions of dollars basically creating infrastructure to prevent what we see here, which is a sunny day flooding event. So that basically happens when there's no precipitation and this water is rising up into the streets. So they've built up their roads, they've replaced a lot of their aging infrastructure, stormwater systems, in order to prevent that from happening and damaging property. So if you want to look at kind of how sea level is going to impact your specific community, Miami-Dade County has a website, miamidade.gov/resilience, where they have this interesting tool called the 3D Sea Level Rise Viewer, which you can kind of you know, map out basically how sea level rise is going to impact you. And so community planners, residents, you know, and others can use this tool as well as some of the other tools at this website to kind of see how sea level rise is going to impact on the local level. Related to sea level rise is saltwater intrusion. So saltwater intrusion is the movement of salt water into our freshwater aquifers, and that's underground through our underlying bedrock. And here in South Florida, we have this very porous limestone, and our drinking water sources sit in these aquifers. So here in South Florida, we have the Biscayne Aquifer, which supplies drinking water to about 5.8 million residents in both South Florida and the Keys. And then overarching that is the Floridan Aquifer, which extends all the way up into Georgia. And really, this is our main drinking water source. And so as sea levels rise, the salt water pushes inland like a parabolic curve, and the deeper you go, the more salt water there is, and it moves inland. So that is going to obviously compromise our drinking water sources, and it's going to become more expensive. Right now, we're not really in a, like other places around the country, in a freshwater shortage, but when we have more saltwater intrusion, it's going to be more expensive to drill wells to retrieve this fresh water, and it's for communities that are already impacted. It's going to be even more negative impacts to these low-income communities in terms of getting that water. And one other area that it's going to become more expensive, we might end up having to do more desalinization, which is actually removing the salt water from the water, and that's very costly. Moving on to extreme weather, and here in South Florida, I want to focus on our hurricane season as that's coming up here on Monday, June 1st. With climate change has been linked to severe weather, and specifically tropical cyclones. So tropical cyclones form in the tropics around the world. Here in South Florida, these hurricanes, these tropical storms have impacted us quite a bit, but as the sea surface temperatures, as I mentioned earlier, as they increase across global basins, because of that warming of the oceans, we're going to see stronger storms. So how does that work? So the drivers, again, are that sea surface temperature, sea level rise, and rising global temperatures. That can lead to, because hurricanes gather their strength from the sea surface below them, they use that heat, and that can increase the amount of, increase the wind and increase the amount of precipitation. So we're gonna have, look at this image here is from Dorian last year. That storm was one of the, most catastrophic on record. It basically sat over the Bahamas and dropped a ton of rain, and the winds were very high. So we're going to see an increase in the frequency of these stronger storms because of that. When we talk about sea level rise, we're already seeing that here in South Florida. And when we have higher storm surge from these storms, it's exacerbated by this rise in sea levels. So we're going to see more areas being inundated and higher storm surges. This image is from Hurricane Irma in 2017. And that, again, is our, Brickell and downtown. And so we're going to have to, we'll talk about these things later, but, either adapt and build up our infrastructure in order to better withstand these storms. And then lastly, with rising global temperatures, we're going to see an expansion of the region around the world in which these storms can form, putting more areas at risk. Related to weather, let's talk about extreme heat. So, of course, with these rising global temperatures, we're going to see what we call more danger days. So those are days when we see the heat index above 105 degrees Fahrenheit. So this image from Climate Central, you can see, is specific to Miami. By 2050, we're expected to see 151 days out of the year that could be, with that heat index above 105 degrees. So that's going to lead to extreme heat is related to a lot of heat or a lot of health stresses, including stroke, dehydration, kidney disease, respiratory disease, cardiovascular failure. You think about all the individuals that their job requires them to be outside. Our frontline workers like policemen and firefighters, paramedics. We think about our agricultural workers and construction workers. All these people are going to be at risk when we have this kind of these kind of changes when it comes to our climate. Again, let's talk about tourism. Here in Florida, this is a major driver of our economy. And when we talk about some of the impacts from climate change, we'll start with the extreme heat, like I just mentioned, which can also lead to more vector-borne diseases, another health impact. And then again, extreme weather events like hurricanes can exacerbate things like erosion. And we can see erosion from both that and sea level rise. We also see coral reef bleaching and even death. Again, not just the ocean acidification impacts the coral reefs, but again, these resources that the tourism industry rely upon, you know, as well as our fisheries to drive that tourism, we're going to see these impacts. We mentioned how ocean acidification will impact our marine food webs. This is going to impact our fisheries. And so there's a lot of impacts there. And overall, according to the Union of Concerned Scientists, we could see an industry could lose 178 billion annually by 2100. So definitely things that we need to think about here in Florida related to climate change. With that, I'm going to pass it back to Heather, and she's going to go into the solutions portion of this webinar and talk a little bit more about that. Thanks.
So thanks, Ed. Just as there are impacts due to climate change, the good news is there are solutions. And solutions are categorized into two main groups: mitigation and adaption. Adaption refers to adjusting to the effects of climate change. So for example, building seawalls or raising roads. Mitigation refers to addressing the causes of climate change. So looking for ways to lower carbon emissions. For example, alternative forms of energy. Mitigation solutions can be accomplished at individual, local, state, federal, and global levels. One mitigation solution is to go solar. So getting off the electric grid and going solar will definitely help to reduce our carbon emissions. There is a federal solar tax credit of 26% deduction from your federal taxes to go solar. Florida ranks third in solar potential, and calls itself the Sunshine State. But when it comes to the use of solar power, it trails 19 other states. Switching to solar can also help our local economy or the state's economy by creating jobs. Another option is reducing your food waste and taking a closer look at your diet. So when it comes to methane emissions, meat and dairy are the highest methane emitters when it comes to agriculture. So maybe eliminating one of your steak dinners will help lower your carbon footprint. And studies also show that people on vegetarian or vegan diets are healthier and at lower risk for certain diseases, including cancers, type 2 diabetes, hypertension, obesity, and heart disease. Another thing to look at is food waste. If food waste were a country, it would be the third largest greenhouse gas emitter. So when you're looking at going grocery shopping, a few things to keep in mind would be to make a list to ensure you are keeping within your range and not overbuying. Don't go to the store hungry. Sometimes there are what we call ugly fruits and vegetables, or ones that don't look as appealing as other ones that would go to waste. So maybe buying those, they're going to taste the same even though they don't look cute. And composting and starting a compost pile in your home to help eliminate food scraps going into the landfills. When food scraps go to landfills, they actually release methane. So if you compost, you're creating a great soil source that you can use in your garden at home. Planting trees is another great solution. According to NASA climate study, by planting more than 500 billion trees, we could capture about 205 gigatons of carbon, reducing atmospheric carbon for about 25%. That's enough to negate about 20 years of human-produced carbon emissions at the current rate, or by about half of all carbon emitted by humans since 1960. Not only are trees great sequesters of carbon, but they also help in other aspects in keeping the environment clean, including helping with storm runoff and keeping air clean by being air pollute absorbers. They absorb pollution in the air. There we go. Another great solution is preserving coastal habitats. Coastal ecosystems play a key role in helping to mitigate climate change. Not only do they provide important ecological services when it comes to protecting the mainland against severe weather events, such as being storm surge buffers and lessening the impact of winds, but they also sequester or hold more carbon dioxide than terrestrial plants do. Every year, coastal wetlands sequester enough carbon dioxide to offset the burning of over 1 billion barrels of oil. Coastal wetlands cover less than 1% of the ocean, but store over 50% of the seabed's carbon reserves. 726 tons of coal emissions are offset by 1 hectare of mangrove. 1 hectare of seagrass can store 2 times more carbon captured by an average terrestrial forest, and coastal wetlands are the only habitat that can continuously sequester and store carbon in soil for millennia. So a solution or a mitigation solution that came at a global or international policy rate was the 2015 Paris Accord, which was an agreement between countries to reduce their emissions individually. The goal of the Paris Accord is to limit the increase of global temperatures to 1.5 degrees Celsius. Under the Paris Agreement, each country must determine a plan and regularly report on the contribution that it undertakes to mitigate global warming. No mechanism forces a country to set specific emissions target by a specific date, but each target should go beyond the previously set targets. In June 2017, US President Donald Trump announced his intention to withdraw the United States from the agreement. Under the agreement, the earliest effective date withdrawal for the US is November 2020, shortly before the end of President Trump's 2016 term. In practice, changes in United States policy that are contrary to the Paris Agreement have already gone into play. So what can you do to help bring awareness to climate change? You can be a climate crusader. And how can you do that? Well, you can talk to a friend or neighbor about what you've learned today, read more about climate change and educate yourself on this topic, sign up to receive a climate newsletter, attend a public meeting, join a local organization, group, or club, write a letter to your elected officials expressing your concerns about climate change. You can get in contact with the Clio Institute and become a Clio climate speaker. You can go electric or solar, maybe change how you're eating. And you can always do 3 main things, which is use your voice, use your vote, and use your wallet. Really look at people you do business with and companies you do business with, and see if they practice sustainable solutions. So your voice, your vote, and your wallet are your strongest superpowers. So with that, we're going to go ahead and launch the poll for you all again. Please answer all 5 questions. And once we close the poll, we'll go over the answers to those questions. Let's start wrapping up the poll. Let's give it about 15 more seconds. And we can close the poll now. And Ed, would you like to review the
Sure.
questions?
So let's go ahead and go through them. Thank you all for filling out the poll. So number one, true or false, greenhouse gases naturally occur in the Earth's atmosphere. That is true. Good job. Which greenhouse gas is the main driver of climate change? The answer is carbon dioxide. Number three, why are forests important for mitigating climate change? So forests serve as a sink in the carbon cycle. That's correct. Number four, what are some actions that we can take locally to adapt to the effects of climate change? We can invest in renewable energies, we can plant trees, we can shop locally and sustainably, and we can compost. So the answer is all of the above. Number five, climate change refers only to the increasing temperature of the Earth's surface. That's false. Good job, everyone. All right. With that, I'll pass it back to Anna, and she will go ahead and see if we have any questions. Thank you guys all for joining us today.